This is John Black, Super Chemist. This is not an instructional video. It is just a blog showing a video account of some chemistry experiments I have done or am learning about. I do not go over all safety concerns, so if you repeat anything in the video, you do it at your own risk. This is John Black, Super Chemist. We're here to make some silver nitrite, not nitrate, but nitrite with an I. I have 125.7 grams of silver nitrate on the left. On the right, I have 51 grams of sodium nitrite. I'm going to dissolve both of them in water, 100 milliliters. And if that doesn't work, I'll put a little bit more water in. I don't want it to be too much water. You know what I'm saying? So I'm going to stir that up, put a stir bar in there, stir it up and see how it goes. All right, I ended up putting 100 milliliters extra into each solution. Now I'm just going to mix them together. It's kind of like making benzoic acid. Precips forward, precips out. I'm going to clean out my cup a little bit there with some water. And I'm going to turn that stirrer on. Alright, so it's too thick to use my stir bar. I'm going to have to stir it by hand for maybe 20 minutes or something like that. Alright, so let's start at about 15 minutes. I'm going to filter it. I'm going to have to do this on 2 shots. It's not fitting into the, it's not all fitting into my thing. My big prick funnel is broke, and this is all I got left here is these little ones. So anyways, I want to leave that on there till it stops dripping and it's nice and dry. So I got it all dry, as you can see. And I'm going to put some ice cold water in there. Maybe about, fill it up so see how it's all filled. Stir it around. And then I'm going to filter it again with the vacuum pump. And keep it on there until it's somewhat dry. Then I'm going to do the same thing with, I have some ethanol azeotrope, and I'm going to do the same thing maybe 2 times with that, and then I'll finish this other half of the batch. Well, there it is. It's yellow. Started out white, as it turned yellow as whatever. It's a nice color though. It's very clean yellow. It definitely weighs too much. It's like 30 grams heavier than it should be. So I'm going to put it in a dessicator. Well, there we go. I got some calcium chloride anhydrous, that white stuff on the bottom, and then I got my product, the yellow stuff in the middle there. And I'm going to put cellophane over top of this so that none of the air escapes. And that calcium chloride will soak up all the water from the air, make it so dry that this will start evaporating into the air, the water in my product. Okay, so there you go. I got cellophane over top of this. Made sure that it's all nice and tight so no air gets in and out. And I'm going to keep in mind, this is light sensitive stuff here that you're making. So you want to put this in a dark place, or what I'm going to do is get some aluminum foil and wrap it all up with aluminum foil and let it sit for a while. Alright, so this has been sitting for a couple weeks. I'm not too lazy to get out of bed. Definitely looks drier. You can't tell on film, but that does look wetter in there, that calcium chloride. I can feel the bottom is still wet. In my eyes, it shouldn't clump if it's totally dry. You can see there's still clumps. Let's weigh it up. Oh, thank God. It's 107 grams. That's actually very good. I got a loss, though. I did get some loss. So I'm going to cellophane that up. And I'm going to Reynolds wrap it all the way around so it doesn't. Put a gum band around it. And the nice thing about using calcium chloride to do this instead of like magnesium sulfate or molecular sieves is a lot of the stuff that's evaporating is alcohol, ethanol. And calcium chloride will form coordination complexes, dative bonds with small alcohols like methanol and ethanol. So this not only is a desiccant for water, it's a desiccant for ethanol. Okay, and that's why I use calcium chloride and not magnesium sulfate. Here's the molar masses. Um, I went by how much silver nitrate I had, which was 74% of a mole. So I took everything multiplied everything by 0.74 to get these equation. I mean, these grams, that's how much silver nitrate, that's how much sodium nitrite, and this is how much my theoretical yield of silver nitrite should be, almost 114 grams. Now I only got 107, so I divided to get the yield, which is a 94% yield. All right, now after we mixed them both together, right, we had the silver nitrite, precip out, and we used water to wash the precip, right? We filtered it, got the liquid out of there, and then we put some water in there, stirred it up, and let it dissolve some of the impurities out. Here is silver nitrate, sodium nitrite, and our product silver nitrite. 0 degrees and 20 degrees Celsius. These are the solubilities in grams per 100 milliliters of water. Okay, at 0 and whatever. This one I couldn't find except at 15, so that's at 15. You can see you barely have any solubility of the silver nitrite. I should have cooled it down before I filtered it to make sure that all the silver nitrite would precip out. I used about 200 milliliters of water on the silver nitrate and 200 milliliters on the sodium nitrite to get them dissolved. That's 400 milliliters right there, and another 100 milliliters, say, to wash it. So that's 500 milliliters. So I times this by both of these by 5 to see how much loss I would get, because that's how much is going to be dissolved in the water. If I would have chilled it, it would only been 0.775 grams, the dissolved that I lost. But I did mine at room temperature, so I lost 1.375 grams. Total, though, my yield, I lost 7 grams. I don't know how I lost so much. So remember, we did 3 washes. The first one was water, and the second 2 was ethanol. Well, actually, ethanol azeotrope. But I want you to look if I would have used pure ethanol. Silver nitrite is insoluble in ethanol, whereas silver nitrate and sodium nitrite, which would be your impurities at the end, they're soluble. Now, silver nitrate, that's about, at room temperature, is about 3.1 grams in every 100 milliliters of ethanol. Sodium nitrite, I'm not sure. It is soluble in ethanol. I'm just not sure how much. In methanol, it's 4.4 grams in 100 milliliters of methanol. So it's probably similar in ethanol. So when you do your water washes, you are actually taking some of your silver nitrite away because you're trying to get rid of your impurities, right? But you're also taking some of your product away. When you use the ethanol, if it's pure, it still takes away your impurities, but it doesn't take any of your product away because that's insoluble. So maybe better not even to use a water wash. You figure when I mixed them together and I got the precip before I even filtered anything, there was 400 milliliters of water there. So I mean, that's easily enough to absorb, make your silver nitrate and sodium nitrite impurities come out that didn't react. And keep in mind, you're only going to have a gram at most of anything. You figure, this is, what you put in, you're going to get out. This is almost a quantitative experiment. So you shouldn't have that much impurities where you need to use the water, I don't think. Now you would also have about 61 grams of sodium nitrate, not nitrite, nitrate, that you're making. But that could easily be dissolved in 100 milliliters of water. And remember, I had 400 milliliters to start with. So that should easily be able to be taken away. And it is soluble in ethanol. So the 400 milliliters should have taken it away. And what wasn't taken away, if you did 3 washes of pure ethanol, it should be able to take away that little bit that's left there. Like I said, this is the first time I've done this experiment. I've never done it without using the water, so I don't know. But it adds up that maybe you shouldn't even use water to wash it. You already have the silver nitrate and sodium nitrite in water at the get-go when you mix them together before anything even precips out. You have 400 milliliters of water. That should easily be able to soak up your impurities. And then the ethanol washes would soak up a little bit more and also wash off the silver nitrite without dissolving any of it. But anyways, keep in mind that when I put it into the dessicator, I evaporated off 37 grams of liquid ethanol and water, probably mostly ethanol. I used an azeotrope, so there was some water in there. But 37 grams of liquid got evaporated off of there. That's a lot, man. Okay, now what would I do different about this to try to get more than 94% yield? Number one, I would cool down the silver nitrate solution before filtering it, just to get as much precip out as I could, even though it's just a little bit. Second, I would use 100% ethanol instead of the azeotrope for the washings. And third, I would only wash with the silver nitrite with ethanol and not water. Remember, the first wash I used water, then I used 2 washes of ethanol. I would switch that to 3 washes of ethanol, pure ethanol, not azeotrope. And that's basically the only thing I would do different. I can't complain, 94% is still good. But I suspected that I would got better than that, slightly better. Anyways, y'all have a great day, and always remember, science is great.